All right, this is lesson 5.2, direct variation. What we're going to do is learn how to write and graph an equation of a direct variation. A direct variation, just so you know, is a linear relationship, linear function, and it's a pretty simple form of one. So we're going to do a little review here. Go ahead and try these problems ahead of time, and then you can check back, pause if you want. All right, identifying a direct variation. And the equation is the equation of direct variation. If it is, find the constant of variation. We should do a quick little review here. A function in the form y equals k times x, where k is not equal to 0, represents a direct variation. The constant of variation k is the coefficient of x. To determine whether an equation represents a direct variation, solve it for y. If you can write the equation in the form y equals some constant times x, then it represents a direct variation. So we want to solve this for y. To do that, I'm just going to divide both sides by 4. When I do that, I get y equals 5 divided by 4 is 1.25 times x. Now we can see that this is in this form, y equals k times x. K is equal to 1.25. So this is direct variation. We'll say yes. The second one, to solve that for y, we're going to use the subtraction property of equality. Subtract 2x from both sides. And now we get 3y is equal to 6 minus 2x, or negative 2x plus 6, using the commutative property. And now I'm going to use the division property of equality, divide both sides by 3, and I get y is equal to negative 2/3 times x plus 2. And this equation is not in this form, y equals some constant times x. And the reason why is because we have this added 2 on the end, so this is not direct variation. All right, go ahead and pause and see if you can do the next problem. Check back for the answer. All right, suppose y varies directly with x and y equals 40 when x equals 8. What direct variation equation relates x and y? What is the value of y when x equals 12? So when we say y varies directly, we're basically saying this is a direct variation. And since it's a direct variation, that means we should be able to write it in this form. And I know a couple values, one for x and one for y, so I can substitute those in. When I do that, I can solve it and find k. So y is 40, we'll put 40 where the y is. X is 8, so we'll put 8 where the x is. Then we'll divide both sides by 8 and get 5 is equal to k. So my constant variation is k. And so the equation that relates these two values is y equals 5 times k. Now we want to know the value of y when x is 12. To find that, we'll just substitute 12 for x and multiply. get y is equal to 60. All right, go ahead and see if you can do this problem. I'll write down the answers for you. If you want to pause and check back, that'd be great. All right, graphing a direct variation. Suppose $15 US is worth about $150 Mexican pesos. What is an equation that relates US dollars X to Mexican pesos Y? All right, so let's set up an equation here as a direct variation. If that's true, then we can say that since $15 is our US dollars and our Mexican pesos are Y, we can substitute 15 for X, and we can substitute 150 for Y, and we can divide both sides by 15, and we get K is 10. So our constant of variation is 10. Basically what we're saying is that you get 10 Mexican pesos for every dollar. Or the number of pesos is 10 times the number of dollars. So our equation is y equals 10x. So if you think about a table of input-output values for that, this being dollars. So $0 is 0 pesos, $1 is 10 pesos, $2 is 20 pesos, $3 is 30 pesos, and so on. That would produce a graph that looks like this. And this is somewhat continuous, although you might call it discrete because you can only have cents. But there are many cents between each dollar, so we're going to draw a line. And notice one thing that's common to all direct variations, and that's they start at the origin and they go up from there in a linear way and actually proportional way. For every dollar there's a proportional, or for every X value there's a proportional amount of Y value. So go ahead and try this problem. See if you can come up with the right answer. All right, the graph of the direct variation y cascaded x is a line with the following properties. The line must pass through the point 0, 0, which is called the origin. And the slope of the line is a constant. So basically it's a linear relationship that passes through the origin. So I don't know if the question is here, but we're wondering, is it a direct variation? All right? To see if it is, it must pass through the origin. If it passes through the origin, that means that 0, 0 is a solution for x and y, so we can substitute 0 in there for x and 0 in there for y, and it should be true. And 0 plus 0 equals 3 is not true. So that's false. So this is not a direct variation because it does not pass through 0, 0. All right, problem 4. Put the data in the table. Does y vary directly with x? If it does, write an equation. All right, just a little side note. Since if it's a direct variation, we can write it as a constant times x for the equation. If I solve this for k, I get that my constant is equal to y divided by x. So what we're saying here is if I take any y value divided by the x value, I get the same constant. If that's true, it's a direct variation. So we're going to apply that right here. We're going to look at the ratio of y to x. If we always get the same number, then we know it's a direct variation. So we're going to do 5 divided by 2, 15 divided by 6, 25 divided by 10. You might remember I said earlier that another way of saying direct variation is saying that that the variables are directly proportional. In other words, the ratios are always the same when you divide y by x, and in this case it's true for all these ratios. We get 2.5. So we're going to say yes, it's a direct variation, and our constant of variation is 2.5. And so we can write an equation y equals 2.5x to represent that relationship. Again, over here, we're going to divide y by x. So 7 divided by 1, 10 divided by 3, 13 divided by 5. And I hope you're thinking already that those ratios aren't all the same. 7 divided by 1 is not the same as 10 divided by 3. And since we don't have a constant ratio, it is not a direct variation. And that's because there is no constant ratio. Or we can say the numbers aren't proportional. All right, so go ahead and try this problem. So here we notice that we always get the same ratio. So does y vary directly with x? Yes, it does. And the direct variation equation that represents that is negative 0.75 times x, or negative 3/4 times x. We want to write it as a fraction. All right, the lesson check. See if you understand what's going on. Ordered pair 0, 0 is always a solution of a direct variation equation. I believe that is true. And we can prove that just by substituting 0 for y and 0 for x and showing that 0 is equal to 0. So that statement is always true. Is y equal k plus x of the form y equals k times x? I don't think so. So the statement is never true. And when you divide each side of y equals k times x by x, you obtain y equals, or k equals y divided by x. That is true unless x is 0. Because you cannot divide by 0, this statement is sometimes, pretty much always true, but we have to take into consideration the unlikely condition where we're dividing by 0. All right, that's it. We'll see you tomorrow.